This is lesson 3.6. I want to mention this is our last lesson of chapter 3 already. Isn't that crazy?
Yay.
Which means we have tests coming up, but it's not next week. It'll be the Monday after. We can chat about that later. All right. Students, we're just working on these warm-up problems, so I'm going to go over them quick as a review from 3.5. Okay, they want us to use this diagram to the left. Determine which lines, if any, are parallel. State the converse that proves the lines would be parallel. Okay, number 1 says we know angle 2 is congruent to angle 9. All right, the line that makes up both of those angles is S. That's the transversal. So the two lines we'd be trying to prove parallel would be the other two lines that make up those angles, U and V. So if you were trying to prove that R and S are parallel, neither of these angles are on line R. So we're trying to show that U and V are parallel. Okay, so based on this information that angle 2 is congruent to angle 9, could we say that U is parallel to V? Yes. Because what's the relationship between angle 2 and 9? Alternate exterior. And the alternate exterior converse says if you have a pair of alternate exterior angles that are congruent, the lines are parallel. Alternate exterior converse. Okay. Next one, number 2, says we know that the measure of angle 7 plus the measure of angle 8 add up to 180. Okay, they're not a linear pair, they're not supplementary, but I see that they both have line V, so that'd be the transversal. All right, so in this case, the two lines I'd be trying to show are parallel would be R and S. Could we say R and S is parallel with this information? Yes. Why? What's their relationship, 7 and 8?
They equal 180.
Okay, what's their classification though? Tyson? Consecutive interior angle converse says if you have a pair of consecutive, meaning on the same side of the transversal, interior angles inside the parallel lines, if you have a pair of consecutive interior angles that add up to 180, then the lines are parallel. Okay, last one. We know angle 3 is congruent to angle 5. So my transversal in this case is line S again. So we're trying to show or determine if U and V are parallel in this case. Is that enough information to determine U and V are parallel? Yes. Okay, what's their relationship? Alternate interior. Good. Alternate interior converse says if you have a pair of interior angles that are congruent, then the lines are parallel. All right. Anybody 3 for 3? 4, 5, 6. Sweet. All right, last one. Throwing a little algebra into the mix here. It says find X so that line P is parallel to line Q. All right. These angles, what's their classification? Consecutive interior. Interior, inside the lines. Consecutive, same side. So in order for these two lines to be parallel, those two are not the same. No, no, no. They add up to 180. Okay, I think I got X to be 9 when I solved this. And the theorem used, consecutive interior converse. Okay, there's a little review over 3.5 for ya. So today, I like this lesson because it kind of combines something we talked about in chapter 1, distance between points. And it's going to connect what we talked about with perpendicular and even like parallel lines. So it's like a bunch of concepts we learned all put together in really long problems. In my 7th hour, we only got through 2 total problems, whole class. Okay. So whatever we don't get done in the notes today, we'll do Monday. Tuesday and Wednesday will both be work days because Wednesday's like a short class anyways with parent-teacher conferences. Thursday we'll have our final quiz. Friday review day. Chapter 3 test Monday. Okay, so today and Monday are the last like notes that you have to listen to me teach. That gives you a good incentive to pay attention today. Okay. Oh no, I lost some points here. That's okay, I'll draw them in. All right, let me ask you this question. If I have a line, like line AB, and I have some other random point that's not on my line, what would be the shortest distance from this point to this line? Any guesses? What would be the shortest distance? Tyson?
Perpendicular line.
Nice. A perpendicular line because we'd want to travel straight to the line, right? So do your best to draw a straight line that would form a right angle, a perpendicular line. Nice job, Tyson. That would be the shortest distance. It's kind of like saying, if I look at the second set of desks here, this second row, like Lillian's and Kaylee's, this row right here. And I was like, all right, what's the shortest distance for me to walk to the second row of desk? Would it be to go all the way here to Kaylee's desk? No, that would definitely not be the shortest. It would just be straight as perpendicular to this row of desk as possible, right? Okay, so it's, write this in your notes, a perpendicular line that goes through the point. In this case, I was talking about point P. So it's a perpendicular line that goes through the point. So we could like extend this line if we wanted to. But it would have to go through point P and be perpendicular to the line. Okay, let's try some example here with, okay, it says construct. We're not actually going to use the tools. Okay, there is ways you can do this with your compass and your straight edge, but we're just going to do our best. If you want to use a straight edge, you can. We're going to do our best to draw like the perpendicular segment from the point to the line. So number 1 in this triangle, they want me the distance, the shortest distance from point C, the top of my triangle, to this line AB, the bottom of my triangle. So do your best to draw straight down perpendicular to that side AB. That would be the shortest segment there. Okay? To this line, you can extend it if you need to. That line that's going through AB. Draw a right angle too. To say it's perpendicular. All right. Point D to line AB. Number 2, you're like, well, again, we can extend this line. If you extend this line, use your straight edge, it might be easier to see. It can lie outside the polygon. In this case, it does. That's fine. That would be the shortest distance to that line. Okay, kind of fun, huh? Okay, you guys try 3 and 4. T to line RS. S to line PQ. Number 4 is probably easier because from point S to PQ would be like right down the middle of that pentagon. I have a quadrilateral in number 3. Let's see, T to RS. Probably gonna have to extend RS here a little bit. So point T. Okay, I'll turn my list here. Something like that. Probably just right outside that quadrilateral. Okay, those are what some of your homework problems are like, where you get to draw. Yes, there is a way to do it with your tools and figure out exactly where it is, but we're just approximating for now. Okay, now the fun begins, these very long problems. Got you? So I gave you a full page to do one problem, and we're going to break it down in 4 steps. And I'm going to give you a nice visual on my good friend, Desmos. Anybody used Desmos before? No.
He sounds like an unlikable friend.
No, he's not. Or she. I don't know. Desmos. It's an online graphing calculator. It's a good time. We use this a lot in I use it a lot in algebra. Like when classes do graph and look at stuff, algebra 2, stuff like that. We don't use it a whole lot in geometry, but today we get to. Okay, so if you look at the problem on your paper, we are trying to find the distance from point P, which is located at 310, to line AB. And line AB contains these 2 points. Okay, so I'm going to graph this on here to give you a visual. So let's start with those points on line AB. So we have 4, 3. Okay, you can see it's red over there, 4, 3. And -2, 0. All right, so there's 2 points that lie on AB. Obviously, there's only exactly one line that goes through those points, right? And we're going to find that line in a second. So what we're trying to do is we're trying to find the distance from point P. So I'll put P up here. It's at 310. You can't see it because it's way up here. There's P. We're trying to find the shortest distance from this point to the line that goes through these points. Okay, that's what we're trying to do. So the first thing we're going to do is find the equation of this line that goes through the blue and the red points. Okay, because it only takes 2 points to find the slope. And then we can go ahead and write our equation of our lines, just like we've been doing for a while now. Okay, so step 1 here, find the equation of line AB. That's these 2 points. Let's start with our slope. Change in y over change in x. 0 minus 3 over -2 minus 4. We get -3 over -6, which is 1/2. All right, now based upon my 2 points, are either of those my y-intercept? No, this one's my x-intercept. But it's not my y-intercept, so I'm going to have to do point slope form, right? I'm going to have to do y minus y1 equals m, x minus x1. You can plug in either point. I'm probably going to use this one because it has a 0. So I can do 0 for y1 if I'm using the point -2, 0. My slope is 1/2. X minus -2 would turn into x plus 2. Okay, we're going to write this in slope-intercept form. This one's not too bad because y minus 0 is just y. Distribute the 1/2. Half of 2 is 1. Okay, so there's part 1. We found the equation of line AB. Now the cool thing about Desmos, it can graph lines too. So go ahead, I'll do this in purple. See if that is indeed the equation that goes through these 2 points. So y equals 1/2 x plus 1. Okay, see how that purple line goes through those 2 points? Okay, you guys just found that equation that went through the 2 points. Good job. All right, so let me ask you this. What would be the shortest distance from this point to this line?
Whatever makes a 90-degree angle.
Yep, 90-degree angle. Alejandro, want to add to that?
I was going to say starting at the point and going -2, 1 in the slope.
Oh, I like it. -2, 1 for the slope. Why?
Because that's perpendicular.
Right, nice. We're trying to find perpendicular. Okay, you're actually 1 step ahead of me. We're trying to find, now we're going to find this line perpendicular. Okay? Perpendicular to the purple line, but goes through point 310, point P. Now, we know what the slope of this line is. We do. Since, I'm on step 2 now. Since we're perpendicular, because that's the shortest distance, perpendicular to line AB, Alejandro said this perfectly, the slope is going to be the opposite, negative, reciprocal, 2 over 1. The slope is going to be -2. So we know the slope, and we know point P is 310. So now we can write the equation of that line. Y minus y1, I'm not going to rewrite out point slope form. Y minus y1 equals m x minus x1. Okay, slope intercept form, and now we can plot it on decimals and see if this makes sense. All right, add 10. All right, that would be the equation of the line perpendicular to line AB passing through the point 310. Okay, should we see if it fits my little sketch here? Oh, I just got off a little. All right, so we got y equals -2, x plus 16. Look at that. Looks pretty perpendicular, doesn't it? Okay, halfway home. The next thing we need to do, because we're trying to find this distance, and it's not just straight across, I'm going to have to do distance formula. I know this point is 310. Now I know because we're on decimals, you can figure out what this point is, but you're not going to have decimals. So you're going to have to figure out what that point is where the two lines intersect. Okay, that's the next step. I'm on step 3 now. Is find point, we'll just call it Q. We're going to find where the two lines intersect. So here's my two lines. We have line AB, which is y equals 1/2 x plus 1. And then we have the perpendicular line, which is y equals -2x plus 16. You've done this before in Algebra 1, but here's a little review. If you want to figure out where these two have the same value, or where they cross, or where they have that common point, you're just going to set them equal to each other. And if this is equal to y and this is equal to y, we can do a little substitution, right? So you're going to take this equation of the first line, and you're going to figure out when it's the same value as this line. Set them equal to each other. And solve. Personally, when I solve equations with fractions, I like to times by the common denominator. So I like to times by 2 to get rid of the fraction. You don't have to. You can do it with fractions if you want. I like to do this, which I saw some of you try to do on the last test, but you guys algebraically kind of did it wrong. So here that'd be x. You also have to multiply this number by 2. Everything gets multiplied by 2. This side also. -4x plus 32. That to me just makes it a little bit easier to solve. Then I can add over the 4x. Subtract 2. Divide by 5, and we get x to be 6. We're not done, because we're finding a point. Point Q is what we're calling this. So we found the x-coordinate is 6, but I need to know the y-coordinate. And if we look back at our graph quick, does it make sense that at this point, the x-coordinate is 6? Yeah, we can figure out what the y-coordinate is. But to find the y-coordinate algebraically, take either of your equations, and when x is 6, figure out what y is. So when x is 6, I'm just going to use this one because it doesn't have fractions. Y is -12 plus 16. Y is 4. So I algebraically found that that point where those two lines intersected was 6, 4. I'll come back to this in a second. Let's look at decimal. Let's see if that makes sense. Okay, why it's like having a fit. These lines look like they cross at 6, 4. Yes, they do. Last step. Now you know they cross at 6, 4. And this point is 310, so you just have to find the distance between these 2 points using the distance formula. Oh boy! Do you guys remember the distance formula?
Yep. Sure.
Okay, if you want to write down what P and Q are. P was that point 310. Q was the point 6, 4. So now you're just finding the distance. Here's our distance formula. Doesn't matter which one you call x1 and y1, but you gotta keep it consistent, so I'll do 6 minus 3 squared plus 4 minus 10 squared. Oh, good throwback. It's like we're reviewing chapter 1 already. Okay, how we simplify this, first you gotta subtract, so that'd be 3 squared, and that'd be negative 6 squared. Keep those in parentheses. Sorry, am I going too fast? Okay. Then you can square them. Okay. I don't know if we've had this discussion, but this in your calculator is different than this. Have we talked about this? This is saying we are squaring negative 6, which means we're doing negative 6 times itself 2 times, which a negative times a negative is positive. Some of you do this, and your calculator tells you negative 36. And you're like, what the heck? That's because your calculator does order of operations. If you don't wrap that in parentheses, this says 6 squared. This says 6 squared times negative 1. Order of operations. You have to do exponents first and then multiplication. This is this problem. 6 squared times negative 1. Okay? So negative 6 squared is positive 36. So we would have the square root of 45. Is that distance? Here's how I want you to write your answer. Simplest radical form and decimal. So this one, because 45 is 9 times 5, this would be 3 root 5. That'd be simplest radical form. If you need to do the circle one, cross one method to get there, that's fine. The square root of 45, if you don't know how to do that in your calculator, I'll show you quick. For a decimal. Sorry, I know the lighting isn't the best. Okay, so you gotta hit the square root button, which is right above the one that says like x squared, square root of 45. So we're gonna do 6.71. We'll round it to 2 decimal places. 6.1 units. So you need both answers. Simplest radical form and decimal. Okay, that was one problem. Wasn't that fun though?
Yeah.
It's kind of cool that you did all that work.
The first part's fun, the last part's not.
You don't like the distance formula?
I don't like it.
Okay. All right, I'm gonna have you guys try one, but we're gonna like take it step by step. Okay. Same exact idea. This time I have line L instead of line AB. Line L contains these 2 points. Point P is at 2, 4. Find the distance from point P to line L. Okay, first thing I want you guys to do is write the equation for line L. So here's your 2 points on line L. Start by finding the slope. I'm going to get this set up on decimals so you have a nice visual again. So you guys start by finding the equation for line L for me. Do we all get a slope of -1?
Yeah.
Okay, good. Now find the equation. You're going to have to use point slope form. You can use either point on the line. If you want to try to work ahead of me, you can too. This. Y minus Y1. Let me do this point. Whoa. All right, so you got negative x plus 2. You distributed and did your math correctly for that line. Let me plot it and see if that works. Y equals negative x plus, no, minus 2. Okay, so here's my blue dot for negative 6. Here's my red dot. Good job, you guys. You just found that equation that goes through those. Next step is we want to find this perpendicular line that goes through point P. All right, so you know point P is 2, 4. So you gotta figure out the slope of the perpendicular line. Don't say it out loud. And then write the equation. Slope of perpendicular lines. Yes, that should be minus 2. Sorry, I wrote that wrong. Here. I typed it in decimals correctly. Minus 2. Thanks, Jessa. Good catch. All right, team. If this line has a slope of negative 1, what does the perpendicular line have a slope of? You can shout it out.
Oh, 1.
Positive 1. Opposite. Reciprocal 1 is 1. All right, so this equation now would be y minus 4 equals 1. X minus 2. So you get x plus 2 for this one. All right, let's plot that quick and see if that looks perpendicular and passes through that point P up there. Y equals x plus 2. Okay, passes through point P. Does it look perpendicular to my purple line? Yeah. All right, now you got to find where they intersect. Now, Desmos is telling you the answer, but you're going to have to do this algebraically. So go ahead, take your 2 equations. Set them equal to each other. And find both the x-coordinate and the y-coordinate. Of where those 2 lines intersect. Solve for x first. Where'd you get for x? You can plug it back into either equation. All right, you should have got negative 2, 0. X is negative 2 from that equation, and then plug it back into either equation to solve for y, we get 0. Okay, now you have to find the distance between that point P, which was 2, 4, and point Q, which is negative 2, 0. So again, I'm going to flip back to decimals. You guys just algebraically found that those two lines intersect right there. So now you got to find the distance between those 2 points. Using our good old friend distance formula. All right, we should all be getting 16 plus 16 under a radical. Should be getting the square root of 32. No matter what order you did it in, I kind of did it in a weird order that time. Got a lot of negatives. Doesn't matter. Should still get the square root of 32. All right, the biggest square root that goes into 32 is 16 times 2. So this, in reduced radical form, is 4 root 2. Did somebody get this as a decimal?
5.66.
5.66. Can I get a second? That you got that? You did? Yeah? Okay, thank you. 5.66 units. Those are so fun. Okay. We're not going to do any more in the notes. I'm just going to show you one thing that's going to lead us into our discussion on Monday. So on Monday, we're going to look at parallel lines. So let me just quick make these 2 lines parallel by giving them the same slope. Boom. So I'm going to give you 2 parallel lines on Monday. And we're going to find the distance between the 2 parallel lines. What's the shortest distance between these 2 parallel lines?
The other one.
Perpendicular, right? Right, yeah, the perpendicular line. And that could be really at any point, right? This distance is always going to be the same. Agreed? See that? All right, so kind of use a similar idea that we talked about today, and we'll be able to find the distance between 2 parallel lines by looking at their perpendicular lines that go through them.
Just broke my ladder. Look at the ladder.
Oh, I get it.
Just broke it.
All right, that's a wrap on 3-6 day 1. Stay tuned for more.
Okay.